Okay. So I'm curious what you guys were able to come up with. Did we come up with anything?
Yeah, a little something.
Okay, so what do we have?
I got 2 t values.
You got 2 different t values. Okay, so let's talk about what's one of the t values that you have?
277.
277. And that goes with which day?
October 4th.
October 4th.
Yeah.
So October 4th, the time is 277, and the number of Facebook users on that day was what?
1 billion.
1 billion.
Oh, that's so much more organized than what I was doing.
So if I was going to take this and kind of substitute into an exponential function, I can have 1 equals, we don't know our starting amount, we don't know our base, we know the t value, 277. It's not a final answer yet, but it's getting us there. That starts to look like a formula, right? Okay. What's the other t value that you have?
114.
114. And that was the one for October?
Yeah.
Or sorry, not October, April.
April 24th.
April 24th. And on April 24th, there were how many users?
800 million, but it's 0.8 billion.
0.8 billion.
It says billion.
Because they ask us to do this in billions. You're absolutely right. This is the same thing as 800 million. Okay, so if I was going to use the same kind of setup like this, what can I do?
0.8 equals, and then we still don't know the A or the B.
We still don't know the A. We still don't know the B.
Well, we know the T.
We know the time, T114.
And then that's all I need to do.
Love it. That is actually really far into the process. Okay, so let's look at what we can do with it from here. Because if I'm going to write an equation that describes this whole thing, I need to know what A and B are. I'm going to divide these two things. I'm going to take 1 equals A times B to the 277, and I'm going to divide it by this other one. 0.8 equals A times B to the 114.
And why would we do that?
Good question.
Oh, sorry.
No, I love that you asked that question. If I divide these things, what can I cancel?
A and B.
I can cancel the A. I can't cancel the B because they don't have the same powers. But I can use a property of exponents here.
You can reduce them.
I can reduce them. Do you guys remember how to handle it when we are dividing things that have powers? You subtract the powers. So this would be B to the power of 277 minus 114. And over here, I'm going to have 1 divided by 0.8. So far, so good?
Yeah.
Okay. What is 277 minus 114? Calculator time, absolutely. You said 163? Okay. So now I have B to the power of 163. That reminds me of where we were yesterday, only the numbers were a little different. What can I do with this B to the power of 163?
Huh? What did you say?
I'm still confused. Multiply it.
Not multiply it. What would we do if this was B squared?
We would
Square root it.
Square root it. So what do I want to do here?
Can we square
Are we gonna 8 the root it?
We're gonna 163 root it.
Yeah. Okay.
Oh, I was somewhat close.
Yes, you were quite close, actually. So we're going to take it to the root of 163.
Okay, so, okay.
So if you remember putting this in the calculator, you do the 163 first, and then you push the second key, the green key, and that thing that looks like the top part of a triangle that's missing the bottom. And then you do 1 divided by 0.8.
You gotta type it in, add 163, and then you gotta push.
We're doing 1 divided by 0.8 under the radical.
To divide by 1. Wait, is it?
That's really,
So ghetto.
that's.
Okay, I got 1.
I got 1.05.
Oh,
Let me see.
this is what I got. Oh. I got it.
Okay, so your calculator, we're going to put in some parentheses here. Right here.
Wait, do we
Right.
all need parentheses?
The yellow calculators don't, because it just drags the radical bar over. On like the blue or green or pink calculators, you have to put parentheses around because otherwise it thinks only the first number is what you want under the radical. So if you want the whole thing under the radical, you got to use parentheses there. You guys got about what? 1.0001.
3. Oh.
Yep. 1.0013 or 14 or whatever. So is this growth or decay?
Decay. That's growth.
Growth. How do we know?
It's positive.
Oh, I said it's more than one.
Because it's more than 1, yeah. Growth
I didn't hear that.
more than 1.
She said, I hate
How much more than 1 is it?
not a lot. Like, we're like,
So 0.0014.
Actual.
So as a percent, that's 0.14% growth each day.
Each day?
Because we had time in days, right?
So this is like the same as when we had to take away that and minus 100.
Mm-hmm.
Okay, so.
I'm trying to keep some things consistent for us here.
Oh, thank goodness.
We're trying to look for relationships that keep popping up. All right, so here's the thing. I can take this much information right here, even though I don't know what A is, and I can write an equation from this. Because we have what our B value is.
Oh, so now.
Here's what I could do. I can take the amounts on either of these days, and I can use it as the A value as long as I say T minus this, or T minus this. So I can have the number of Facebook users is equal to 0.8. Which day am I using? Which one has 0.8? April 24th. To the power of T minus 114. Or, what about if I wanted to use this other date? 1 times to the power of T minus 277. These have the exact same meaning. Before I take your question, just real quick. Do you guys remember back to Algebra 2 when you talked about transformations like with A, H, and K? We talked about it a little bit with parabolas. Do you remember what A, H, and K do to things?
Go up.
Yeah. A is like wider, skinnier.
Yep. A controls the stretch.
K is up or down.
K is up and down. What does H control?
The side.
Left and right. This right here is the H value. So it's saying if we shift this 114 days into the future and we have this rate, that's how many users there are. If we take it and we shift it 277 days into the future, this is the number of users and that's our rate. I can do that with any exponential function, even if I don't know the starting amount, but I know how far in we are. I can use that like the h value. You had a question for me?
So the 14 is 0.14% growth, right?
Yes.
Okay, so like if it would have been 0.014, then would the growth have been like 1.4%?
Mm-hmm.
Okay, just making sure. Okay.
Yes.
Okay, so the growth is
Because to get the percent, we times it by 100, and if I times this by 100, it moves it 2 places. Yes. Yep, you are absolutely correct. All right. With our last couple minutes, I want you guys to flip 2 pages forward. So page 123. 123. Exponential functions, which is what we've been talking about. And so this is what I have drawn here. I've got 2 different functions that I'm showing here. One of them is the function f. What's the initial amount on the function f? No. What's my initial amount? C. What's my rate? 3. So it's tripling each whatever, day, week, month, year. It's tripling. What's the other function? G. What's the starting amount on G? D. What's the growth? So it's doubling. Which is faster, tripling or doubling? Tripling. So I'm looking at these 2 graphs and I'm trying to figure out which one is F and which one is G. You said tripling is faster than doubling, right?
so it's steeper.
So I've got this one that's a darker blue here, and I've got this one that's a lighter blue. I know in your book they're both gray.
Yeah.
It's a little darker.
So the one that's the darker blue up on my screen, is that one growing faster or slower? Faster. The darker one is growing faster. It's steeper. So which one is that, F or G? F. This is f of x because it's growing faster. Yes, the light blue one then would have to be g of x. So when I'm thinking about those starting amounts, C and D, we don't have numbers to go with them. But I see here's my function g. Here's where it hits the y-axis. Here's my function f. Here's where it hits the y-axis. They both have y-intercepts. Which one, C or D, is bigger?
Oh, it would be. Wait, what?
It would be the opposite.
Too many letters.
D would, wait.
I feel like it's gonna be.
All right, so
I think D is bigger, yeah.
here's my function f.
Okay, that's
I mean,
bigger.
yeah, D, yeah.
Where is it crossing the y-axis at?
Somewhere.
0.
2. I mean,
Oh, hold on. Go find your function f. What's the starting amount?
3. I mean, what are we on?
I thought we were
Look at our function f. That's what I traced along poorly. Here's where it crosses the y-axis. The y-intercept is the same thing as what?
starting.
The starting amount.
Yeah.
What is the starting amount for our function f?
I thought we don't know.
We don't know, but what are we calling it?
C.
We're calling it C.
Okay. Yes. Yes.
Look where it is on the y-axis.
Yes. Okay.
All right, now I've got the function g,
So 0G.
0d.
Okay. Isn't it?
So which one, C or D, is bigger?
D.
D is bigger. How do you
I
know?
told you
Yeah,
it was gonna be the opposite.
D is bigger.
Okay. So
How do you know?
because it starts up higher on the y-axis.
Because it's higher on the y-axis. Good job. All right. On Monday, we'll answer the second question here, part B, and then we'll have another activity. There is no new homework today. So spend the weekend catching up on any assignments that you need to catch up on. All assignments close and lock 2 weeks from today. May 13th, 2 weeks from today, all the Canvas assignments close and lock. So anything from the entire semester, including the 3 assignments last week, please make sure that you get those into me ASAP.
Are you